Thank you very much for the introduction. It's my pleasure now to introduce Kejie, Dr. Kejie Zhao, who is an associate professor of mechanical engineering. He just got promoted to that this year to that rank. He received his PhD degree in engineering science in 2012 from Harvard, and his bachelor and master's degree from the Jiao University in 2005 and 2008, respectively, in China. After Harvard, he worked as a postdoctoral associate at MIT from 2012 to 2014. Before he joined Purdue then in 2014 as an assistant professor, and like I said, promoted this year. His group focused on the chemomechanics of electrochemically active materials using experimentation and multi-scale modeling approaches. He's a recipient of the EML Young Investigator Award, the 3M Non-Tenured Faculty Award, the ENSM Young Scientist Award, the NSF Career Award, and the James W. Daly Young Investigator Award from the Society of Experimental Mechanics. So you can see he has already in his very young career here at Purdue racked up quite a few awards. He's an outstanding researcher, a super nice colleague in our school, and also an excellent teacher. So I'm really looking forward to hearing from Kejie today.
Thank you very much, Eckhard, for the very kind and generous introduction. Let me share my screen. Does it look good?
Yep, looks good.
All right. Again, thank you, Eckhard, for the introduction. I was asked to give a 10-minute light talk about my career path. So I'm going to talk about from when I was a student to somewhere in the future, and we're currently somewhere in between. I grew up in China. I went to Shenzhen University for my bachelor and a master, both in engineering mechanics. Someone who might know me here might ask, who is that guy there? That was me about 15 years ago. Unfortunately, I have grown in size about twice in the horizontal dimension in the past couple of years. And so let me see, there is a message there. And after that, I went to Harvard for my PhD. And after struggling for a couple of years, I was able to receive my PhD degree in engineering science. And after that, then I moved to MIT. I had the privilege to work with a material scientist at MIT for my postdoc. And right after the graduation and PhD, Purdue was the only school who was willing to interview and offer me the position in school of mechanical engineering. And that made my postdoc life so much enjoyable and stress-free. And from 2014 to the year of question mark, I'm at Purdue. And this is a remarkable moment that my students sent me a flower and a wine to celebrate the promotion during the early spring. And you can see that I never left school. And some students might ask, why did I choose academia as my career? And when I was a student, I was told that there's a lot of freedom in academia, working there as a faculty, and I can work anywhere at any time. And that's indeed true. And every day is a Saturday. And when I started, I quickly realized the other side of the coin is that I had to work on Saturdays. And one of the privileges being a faculty in a university is I was able to work with many talented students. And this is in 2015, my first two students, Dr. Rongxi, who is currently a postdoc in Stanford, and Dr. to be Luis Vasconcelos. And after that, then Hong Sang joined us as a PhD student and also a visiting PhD student to join us, and also recruit a couple undergrad researcher. This was in 2015, 1 year after we started. 2016, I was very delighted to receive a surprise birthday cake and a card from the small group. 2017, the visiting PhD student left, and this was a farewell dinner to that student. 2018, we celebrated Louise's birthday by asking her to give us a group talk during the spring break. In 2019, Ron graduated, he left us. And 2019, we celebrate the Best Paper Award of Louise for Electrochemical Society conference by asking her to buy a nice dinner for us. And since then, the group has grown significantly. And during the lockdown of this year, we had to switch our group party to online. And a couple of months ago, we were able to go out for hiking, and this is part of the group. And very recently, Dr. Hong Sang graduated and left for a postdoc. This is the wall of pictures in my office. This is my most enjoyable place. And you can see from this note, my daughter very accurately described those were happy moments to me, Kejie. My research is focused on mechanics of materials and mechanics of electrochemical systems. My majority publications are about the battery materials, including lithium-ion, sodium-ion, solid-state battery materials. The research question is twofold. We try to understand how the electrochemical processes like mass transport, charge transfer, interfacial reactions induce mechanical stress and mechanical failure of battery materials. And on the other side, we try to understand how the mechanical stress and degradation regulate and impact the battery performance. We do both experiments and modeling. In terms of experiments, we set up the operant experiments so we can monitor the mechanical behavior of battery materials during the exercise of charging and discharging. And we conduct finite modeling to simulate the mechanical behavior of battery materials and particle materials. We also use quantum mechanics-based density functional theory to understand electronic interactions of materials at a very fundamental level. We're also interested in the organic electrochromics. We measure the mechanical breathing strain during the cycles of electrochromic devices. We also use mechanics experiments and design to improve the mechanical reliability of electrochemical devices. Recently, we started working on organic electrochemical transistors. This is a fairly complex system because it involves a mixed ionic and electronic conduction in the system, but it has a very bright future applications in many fields. Currently, we're focused on understanding its multiphysics behind its working principle and its applications. My career project is working on superelastic organic semiconductors. This is a type of molecular crystals that exhibits many rich behaviors such as superelasticity, ferroelasticity, shape memory effects, but dedicated control of the load such as a mechanical load and thermal load, we can achieve those rich behaviors and functions. We focus on molecular mechanism and its fundamental understanding on those mechanical behaviors and also its application in stretchable electronics. My overall vision for research is there's a large room at the interface between mechanics and chemistry. Like my research, I teach mechanics of materials, MES 323. This has been my 10th semester teaching this semester, still enjoy it. I was fortunate to be part of the Impact cohort in spring 2016 and teaching for tomorrow fellowship in another semester. The goal was to increase the students' engagement, autonomy, competence, and relatedness through a redesign of the flipped classroom for this large mechanical engineering class. We use combined pre-lecture videos, online quizzes, and group activities in this class. I was fortunate to be a part of the authorship of a lecture book, and Professor Crossgrove is a leading author of this book, and he did 99% of the work, admittedly. But I was happy that I was able to contribute to this artwork of the front page. At least that's what I did. And after collecting the data of many semesters of the flipped classroom, I worked with a few staff in Center of Instructional Excellence to quantitatively assess the improvement of students' learning perception and performance in the flipped classroom. And we wrote a paper and submitted. I'm a strong believer that it is an endless frontier to improve the climate of classroom, students' learning perception, motivational beliefs, and engagement in large-scale mechanical engineering class. And last and most important, I owe gratitude to many of people here. I'm most thankful to my students. My students are my hands. Without them, I can't simply do anything. I can perhaps only scratch some ideas on the crappy papers. I'm thankful to Dr. Rongxu, Dr. Hongsam, Luizi, Xiaokang. I wish to put down every student's name here, but unfortunately I cannot. I'm sorry about that. I'm grateful to my mentors and colleagues, Professor Thomas Siegmund, who has helped me tremendously over this process, Professor Sedeghi, Professor Crossgrove, Professor Melshi, Professor Arvind Raman, who taught me how to set up the online quizzes and pre-lecture videos. That has been very helpful. That happened in my earlier time in 2015, so I have been using that for the past several years. Professor Yangxin, who donated a scanning electron microscope to my lab for free. I'm very grateful for that. That has been tremendously helpful to my research. Many other colleagues in mechanical engineering. I have collaborators and close friends, Professor May in chemistry, Dr. Liu from SLAC, Professor Lin in Virginia Tech, Dr. Li, Dr. Du, Dr. Hu from National Lab, Professor Zhang from China, Professor Chen from Industrial Engineering, Professor Pan, Professor Mark Kennett from Mechanical Engineering, and Dr. Choi from Center of Instructional Excellence. Okay, I'll stop here, and I thank you, everyone, and thank you for listening to me.
Thank you very much, Kejie. Very nice presentation. I like the personal touch. Always fun.
Thank you, Eichert.
So let me start out with a question for you and see what other questions we're getting. But you have collaborated with quite a few in ME, right? Just based on this list. And you even mentioned like some have been very open to even share equipment, right? Or help you. So what's your secret way to do that? If you give a recommendation to a young incoming faculty, how do you establish these collaboration? Like how do you approach senior faculty that you need to work with them?
Well, thank you for asking this question. There's no really secret way. I think many things happened just naturally. I still clearly remember that when I visited Purdue in 2013, there was so many encouragement. Even then, I was a candidate. And I talked with Professor Song, Steve Song, about ideas. And we kept in contact after that. And when I joined, then I had a chance to briefly stop in their office and just to brainstorm some ideas. I don't see there's any barrier in mechanical engineering. It's very collegiate and a very supportive environment. So as long as we sometimes not even I wanted to reach out to someone, some senior colleagues just came to me, for example, Professor A.G. Maoshi say, hey, Kejie, how about this proposal? And we can do something together. I'm very grateful. I'm very honored and happy to be in such a great environment.
Thank you. Any questions from participants?
I was just going to say anyone can turn their camera on if they want to ask a question as well.
So we still have a little bit of time, and I can bridge over and ask you another question, right? So now, like the burden of tenure, which a lot of assistant professors feel strongly, right, is off your shoulder. Where do you want to take your career? What's next for you? What do you envision? What paths you're going to take in this environment?
Yeah, absolutely. So I want to perhaps address this question in terms of two aspects. The first is about the pressure and the stress during the tenure track. I completely understand this is a very stressful period for many of the junior colleagues, including myself. I thought I put too much pressure on myself at the beginning. And when I looked back now, I feel it's sometimes really not necessary. It's not mentally healthy and does not increase my productivity either. It just made my feeling more miserable at the time of the failure. But of course, we experienced so many failures during this time. So my only 2 cents to junior faculty who has not been tenured here is like, just enjoy the process, you'll be fine. And second is about my future. I just briefly mentioned my overall vision on the research and the teaching. I believe there's a significant room at the interface between mechanics and chemistry, a lot of opportunities, a lot of systems. They share the similar feature, and we can use what I know, what I'm good at, to tackle those systems. And in terms of the teaching, I'm always passionate about teaching. This is, I find teaching is much more rewarding, honestly, than research. So when in the classroom, when I teach face-to-face, and when I see there is facial expression and they say, hey, professor, thank you for teaching us, I got it. I feel really satisfied. So definitely I wanted to increase my interaction with the students, my relativeness with the students, and there's a whole lot of research about teaching. I think this is a great opportunity as well. And in terms of what I should be maybe a little bit more focused on, I think Professor A.G. Maoshi had a very good advice that I should focus on impact. So it's not, now I think I have enough publications already. And perhaps it's not about the numbers, it's really about the quality and about who should care about my research. So that's my 2 cents.
Yeah. Great, thank you. So we have received a question from Peter Mackel. Kejie, what do you see as a future challenge in new battery technologies based on the work you have already done?
Oh, absolutely. So Peter, I can go to your office and give you a full presentation about the challenges of the batteries. So I don't know if you had a chance to see Elon Musk's battery day. And there's the new challenge is how we can increase the charge density and the hours, like for example, the mileage of electric cars. So that is the grand challenge. And to achieve that goal, there's a lot of issues. And so there is a famous saying that in battery field, when you solve one question, you create 10 new questions. So, and regarding the mechanical aspect, people have been gradually realizing that mechanics is actually a bottleneck for those high energy density materials because it is contradictive to the high energy density. So when you want to harvest the high energy density, you have to sacrifice the mechanical reliability. So that's my passion about, and I hope first we want to understand how, on the fundamental level, how the mechanics and the chemistry they're coupled, and how that impact their system performance. At the same time, I'm also interested in the material design to increase the mechanical reliability for those future promising battery technology. Okay. Thank you, Peter, for asking this.
Great, thank you. Any other questions from participants?
So Eckhart, this is AJ. Can I ask a question?
Absolutely, go right ahead, AJ.
Thank you, Eckhart. Kejie, excellent presentation. Your presentation is quite motivating and personal both. I just have one question for you that at Purdue, still myself being a relatively new faculty, I see incredible opportunity. For example, connecting the dots from batteries to connected vehicles to autonomous vehicles. So I think there might be an opportunity you consider that your research battery could really, it is kind of double entendre, but plug in to the various activities around Purdue in connected vehicles, because corridor between Indiana and neighboring state, including Michigan, is becoming very active, and battery will play a huge role. So I just saw as an opportunity to connect the dot what do you do at the cutting edge with others. Thank you, Bert.
Absolutely,
presentation.
Absolutely, AJ. Thank you so much for that advice. I think this is how my mentors helped me. So they always, hey, Kejie, there's an opportunity there. Why don't you think along that way? I really appreciate it on those these advices and suggestions. I'm 100% agree with that opportunity, and it's not just about the materials level or just about the battery itself. It's about the system. So this is a system engineering, and I'll be very happy to learn from my control colleagues, autonomy and vehicle colleagues, and see how the battery can be implemented and how my research can contribute maybe a little bit to the overall system. This is a great advice. Thank you.
Thank you, Kejie. Thank you, AJ, for the question. Any other questions?